wanted to make one last comment about Newton's third law. So let's take a look at this object right here. You have this box, it's being pulled to the right with an applied force of 5 newtons. F sub A means that there's an applied force. Somebody's applying a force pulling to the right with 5 newtons. And then there's a force of friction holding it back 5 newtons. Now this object could either be still or it actually could be moving to the right with uniform motion. Regardless, what would be the net force on that object? Yeah, the net force is the same as the resultant force. Net force equals the resultant force. So basically, if you have 2 forces acting in the opposite direction, how do you find the resultant force? You just have to subtract them. Okay, you could use the component method, okay, and you could draw a head-to-tail diagram, but it just boils down to subtracting them. So we know that 5 minus 5 is 0, so the net force is 0. So those 2 forces cancel each other out. They kind of like negate each other. They balance each other out. So in the end, the resultant force on that object is 0. You with me so far, people?
Yes.
Okay. Well, with Newton's third law, law number 3 from a man named Newton. That's a stretch. Okay. Newton's third law says that, for every action force, say a force of 5 newtons to the left, there is an equal and opposite force exerted. Five newtons to the left. And that is a true statement. This is what Newton's third law says. For every action, there's an equal and opposite reaction. Yes? So, the point I'm trying to make here is, the question I'm trying to answer is, why don't these forces cancel each other out? If you always have these forces basically acting with the same magnitude in the opposite direction, you would think that everything always cancels each other out. And nothing would be accelerating. So that's the question. Why don't these forces cancel each other out? Why don't they cancel each other out? Lola?
Because sometimes they're force putting the force on opposite.
Okay. You hit the nail on the head, especially the first part. Okay. These 2 forces, action-reaction pairs, they never act on the same object. Over here, these 2 forces cancel each other out. They're both acting on the same object, yes? But action-reaction forces never act on the same object. Okay? Why don't they cancel each other out? Because action-reaction forces never act on the same object. it's always like this. Object A exerts a force on object B, and object B simultaneously exerts an equal magnitude but opposite direction force on object A. So there's two objects. Object A pushes object B. Object B pushes back just as hard in the opposite direction on object A. They don't cancel each other out because they never act on the same object.
So is it because they're different objects that it's not canceling? I don't have arms.
When Samantha pushed on Jared, she exerted a force on him. He simultaneously exerted a force on her. Why don't those two forces cancel each other out? They're acting on different objects. If we drew a free body diagram of Jared over here, what force would be acting on him? A force to the right. If we drew a free body diagram for Sammy over here, there would be the same magnitude force acting in the opposite direction. Now, of course, their weight forces and their normal forces would also be acting on them. But the point being, those two forces don't cancel each other out because they're acting on different objects. Can forces cancel each other out? Yeah. You know, you could have other things going on here. You could have another force, over here. But action and reaction never cancel each other out because they act on different objects. Sammy pushed him, so he just experienced one force. He pushed Sammy. She experienced one force. Since they're only both experiencing one unbalanced force, the two forces don't cancel each other out. Each one has a net force, each person accelerated. Yes?
So let's say Sammy and Jared weigh the same, they weren't the same weight, their hair weighs the same.
Everything.
So then, would they both have to go accelerations?
Yes. Yep. So, the little point I'm trying to make is, can forces cancel each other out? Yeah, if you have two forces acting on the same object, yeah, they can. Okay? However, action-reaction forces never cancel each other out because they're acting on different objects. Okay.